In this video, we're going to talk about the idea of radians and how they compare with degrees. Let me remind everyone that when we talked about degrees, the idea was it was decided that if you wanted to measure all the way around and getting back to your starting point, that should be 360 degrees. And if you had any smaller angle, you would just go ahead and say what fraction of a total circle are you including in that angle, and that's how you figure it out. So for example, 90 degrees is 1/4 of 360, and so if you're going 1/4 of the way around, then that's a 90-degree angle. The definition of radian is a little bit different. So if you have a circle, so we're going to start here with our initial side, and this time I'm actually going to label its length as r, and we travel around, and again, since it's a circle, it still has a radius of r here. If you travel around enough to where the length that you traveled along the outside edge here, this is called the arc length, by the way, you'll see the term right here. If we travel just enough to where the amount that we traveled is equal to the radius, then that means the angle is 1 radian. And we usually don't even write down radian as the angle. We certainly don't put down the degree symbol here. A lot of times we literally just say it's 1, which means 1 radian. So 1 radian is whatever angle it takes, so that if you're walking around the outside of the circle, you will have walked a distance that is the exact same as the radius. Now, if you wanted to have 2 radians, that would mean that you would travel around, so you get 1 radius distance there, and keep traveling until you get to the second radius distance, and that would then be 2 radians here. And if you wanted to go 3 radius distance around the outside, your theta, your angle there would be 3 radians, and so on. And so if you think about it, if I wanted to go 5 radius around the outside, the angle is 5. So we have this nice formula that says S, which is the arc length, and again that is the distance along the edge. Then S is equal to the radius multiplied by whatever the angle is that you traveled. So think about this: when your angle is 1 radians, the distance traveled is 1 times r. If your angle is 2 radians, then you will travel 2 radiuses around the outside, and so on. And so this formula gives us a nice relationship that relates how far we traveled around the outside compared to the angle measure here. But the important note is that theta needs to be measured using radians. This formula is absolutely not true if your theta is a degree angle. Now we're about to see how to convert back and forth, so that if I did give you a degree angle and I asked you to find the arc length, you could convert it to a radian angle and use that to calculate the answer. Or if you wanted to, you can change the formula to be working for angles in degree. I'll actually give that to you a little later in this video. But this nice simple formula, S equals R times theta, it only works when you have a radian angle. We're going to have another formula in a later video that's also nice simple formula as long as you have a radian angle, and a more complicated version if you had a degree angle. And because of this, because these formulas work out nicer in radians than in degrees, and not just these formulas but also ones that are used in a class called calculus, that is why once you get to the class that's calculus, you're only going to use radians everywhere. So Right now, generally people are a lot more familiar with degrees. They're more comfortable using it. But at some point in time in your math career, you're going to be switching over to pretty much just using radians everywhere. So now we're learning it and trying to get a little bit used to it. But eventually you're going to want to be able to work in radians just from default. So how do we convert between a radian and a degree? Well, we've already said that one full circle, that is 360 degrees. So we have the degree measure for one full circle. Now let's find the radian measure for one full circle. Well, we have the formula S equals R theta. So we're trying to figure out what is the theta going to be for one full circle. Well, the arc length is how much you had to travel to go around the outside. And if you travel around the whole outside of a circle, we know that for circumference formula, that is 2 pi r. And then the r's cancel. It tells us that the radian angle for one whole circle is 2 pi. And so what this means is that 360 degrees is equal to 2 pi radians. Or in other words, if I say divide both sides by 360 degrees, 1 is the same thing as 2 pi over 360, or reducing it down, pi over 180. So, and you can also take reciprocals of both sides and get 180 over pi. And so this tells us that the number 1 is the same as either pi radians over 180 or 180 degrees over pi radians. We can now use this fact to do the following conversions. The first conversion is 120 degrees to radians. So I'm starting with a degree measure. I want to end up with a radian measure. So I'm going to choose to multiply by 1. But the way I'm going to multiply by 1 is by multiplying by pi on top and 180 degrees on the bottom, which is the same as the number 1 already. Then I will reduce this fraction. I can say 60 goes into 120 2 times, 60 goes into 180 3 times, and the end result is going to be 2 pi over 3. So that means 120 degrees is the same as 2 pi over 3 radians. Going the other direction, our second conversion says I have pi over 4 radians, and I want to convert that to degrees. This time I'm going to multiply by the fraction that has the degrees on top, because that's what I'm looking for. And then we can go ahead and cancel out the pi's here. And 4 goes into 180 45 times. And so pi over 4 is the same as 45 degrees. Now, of course, calculators can do all this work for us. But when we have these nice angles that work out to a special angle, it's probably better to do it this way. However, for these last two conversions, these are not nice angles. These are not 30, 60, 90. It's not 45, 45, 90. So really, we're going to have no choice but to use the calculator here. You multiply by pi over 180. And if I go ahead and do this in my calculator here, 320.4 multiplied by the number pi divided by 180. The only thing that cancels this time is the degree symbol, and we're left with 5.59 radians. On the other hand, over here we have 1.8 radian multiplied by 180 degrees over pi. And again, your calculators probably have a conversion button on them you could use instead of multiplying manually, but this works just fine. And we get 103.13 degrees. So these are the different ways we can use to convert back and forth between radian and degree measure.